All right, inverse trig function. All right, so we're gonna do some crazy trig functions. Last class we looked at something like this: trig inverse of, let's say, radical square root of 3. What is that theta? That's what we solve for. But today we're not gonna use this easy stuff. What we're gonna do, sine of tangent inverse of 1/2. What is that equal to? Well, for that, remember, we look at all students takes classes, how they're positive. This is what we're gonna do. So we're gonna look at this part right here. Let's say tangent inverse of 1/2 equals theta. So tangent of theta equals 1/2. Well, tangent inverse of that, it's positive, so therefore we're looking at what quadrant, guys? We're looking at the first quadrant, right over, boom. It could be in the fourth quadrant, but we're looking at tangent inverse of it, and tangent inverse lives in first and the fourth one. So the fourth one is going to be negative, that's going to be positive. Now we use SOHCAHTOA. For the SOHCAHTOA, this tells us opposite over adjacent. So opposite would be 1, adjacent would be 2. And we could figure out this missing hypotenuse. In this case, missing hypotenuse would be what? Square root of 5. So now we're going to use this triangle to answer the following question. Well, sine inverse of tangent inverse of theta. Well, tangent inverse of theta is what? Sorry, tangent inverse of 1/2 is theta. So I'm just substituting that. Now we're going to go back to this, and we're going to answer ourselves. What is sine of theta? Sine is what? Opposite over hypotenuse. It's that simple. All right, let's do something a little bit complicated. Oh, I've updated the homework. What is what due? As you can see, I've extended last week's homework. I think last week you guys had a lot of things due, so I changed one of the homework, made it due this week. All right. Cosine of sine inverse of -1/3. All right, so let's look at this part right over here. Sine inverse of -1/3 equals theta. So sine of theta equals -1/3. So what quadrant are we talking about? Sine lives in first and the fourth quadrant. Sine inverse lives in the first and the fourth quadrant. Since it's negative, it's going to be on the fourth quadrant. Here's your theta. And we use this opposite over hypotenuse. Opposite over hypotenuse. Don't forget this negative. This negative doesn't go on the hypotenuse. This negative goes on the y side. And it makes sense because the y value on the fourth quadrant is negative. Hypotenuse is always going to be positive. Can we find the missing side? We use the Pythagorean theorem. A squared plus 1 squared equal 3 squared. So a squared equals 9 minus 1. So a is √8. Boom. Now we use this information right over here. Cosine of theta. Cosine of theta equals what? Adjacent over hypotenuse. Square root of 8 over 3. Let's do a little bit harder one. Tangent of cosine inverse of -1/3. This is a little bit hard one. Cosine inverse of -1/3 equals theta. So we're looking at cosine inverse. Cosine inverse is in the first and the second quadrant. Since it's negative, it's going to be on the second quadrant. And here is your theta. And we could do it adjacent over hypotenuse, 1 and 3. Well, we got to put the negative for the 1. Hypotenuse could never be negative. And it makes sense because in the second quadrant, x value is negative. So what's this then? It's going to be square root of 8. So now substitute all this information. Tangent of theta is opposite over hypotenuse, square root of 8 over negative 1, or negative that. So now I'm going to give you a little bit more restrictions. Last time we looked at sine inverse lived in from negative pi over 2 to positive pi over 2. Note it includes the 2 points. Cosine inverse lived in from 0 to pi. And tangent inverse lived in negative pi over 2 to positive pi over 2. So now I'm going to give you secant inverse. Secant inverse lives in 0 to pi, but can't have pi over 2. So basically cannot equal pi over 2. So if you look at the graph of that, secant inverse would be from 0 to pi, but open circle right over here. Cosecant inverse lives from negative pi over 2 to positive pi over 2, but can't equal 0. So that's cosecant inverse. This is secant inverse. And the last one, cotangent inverse. This is a tricky one. It's not going to follow cotangent. It's going to follow 0 to pi. It's just 0 to pi. So it's going to be open circle from 0 to pi. That's cotangent inverse. So let's do the last one. Sine inverse of tangent of u. How do we do this? So let's look at this. Tangent of u is theta. So, oh, sorry, I wrote the question incorrectly. So tangent inverse of u equals theta. So u equals tangent of theta. And we're talking about first and the fourth quadrant. And we're going to assume u is positive. So it's going to be, that's your theta. So it tells you what? Opposite over adjacent, SOHCAHTOA. So u over 1. So what is this missing side? U squared plus 1 squared equal hypotenuse square. So h equals u squared plus 1. Substitute this sucker in. You get sine of theta equals, sine is opposite over hypotenuse. And you're going to see that in calculus through later on. In calculus 2 class, you will see that later on. Okay, so this is the topic I'm covering. This is the topic I'm covering right now. I will see you guys next time.